Today we are learning about the washer method, which is a lot like the disk method, plus what we learned in the last lesson, so 6.1, where you have the intersecting, or you have two functions that are intersecting. So it's a combination of the two. Pretty straightforward since we've talked about it already. And we are also doing a little bit of solids with known cross sections. So first we'll talk about the washer method. So this will come with two functions. So our first example is, oops, that's terrible. A graph that looks like this. So this is going to be f of x, this is going to be g of x, where f of x equals square root of x, and g of x equals x squared. So this is x squared, this is square root of x. So what we're going to do here is, again, we're rotating it. We're going to rotate it around the x-axis. But this time, last time we only had one line here, and we rotated it around. And so we had, oh my goodness, I'm terrible at drawing graphs today. We had something that looked like this when we rotated it around, where all of this volume right there. But now we're doing something like this. Something like this. So the only volume we're dealing with is in here. When we rotate this one around, it'll look something like this. So what we're going to do is we're going to take all this area. Anyways, we're going to take all this area, like up here. We're going to take all, and then we're going to subtract out the stuff that we do not want. So we're going to take all that stuff out. So we're going to use the same method that we used for the disk method. Plus a little more. So we actually have two radii that we want to use. So the outer one, or the top one, is going to be r of x, which equals f of x, because f of x is the top one. And then little r is the inner radii, which is the bottom one. And that's x, that's g of x. Square root of x and x squared. So what we're going to do is we're going to take, so to find the volume, we're going to go from A to B, so where they intersect, right? A, B. We're going to integrate that, and we're doing r of x minus little r of x. Dx. So that's what we're going to do generally for anytime we're trying to find the volume where we have to take out a certain amount. So let's do that really quick. So volume, for this one, again, we are doing something spherical, so we have to do pi r squared. So we're going to have pi, and they will intersect at 0 and 1. So 0 and 1 are the points of intersection, and we are going to square both of these. So rx squared minus little rx squared. So that's going to look like pi from 0 to 1, square root of x squared minus x squared squared dx, like that. So again, this is, or more simply, this is going from 0 to 1. The square root sign and the square are going to cancel, so we're left with x, and then we have x to the fourth, because we got to multiply 2 and 2. dx, and this is simple enough. X squared over 2 minus x to the fifth over 5 plus c times pi from 0 to 1, which will give us 1 over 2 minus 1 over 5 all times pi minus 0. So the pi 5 over 10 minus 2 over 10, which equals pi 3 over 10. So that is our answer. Next, we'll talk about the solids, finding the area of solids with known cross sections. We'll look at example 6. So we have the triangle cross section. We have a function f of x equal to 1 minus x over 2. We have a function g of x, which equals negative 1 plus x over 2. And then our third given is just x equals 0. So that's just going to be the y-axis all the way up. So what that's going to look like is we'll have a graph. So this is our y, this is our x. So we're running along this side, right? And then we have 1 minus x over 2, which is going to be this one going in like this, and another one like that. And I can't draw it in 3D at this point, but it's going to come up something like that. It's following the y-axis though, so we're kind of looking at it tilted like this. So the way we're going to find this is we have to use the area of a pyramid. So we're going to look in the front here for that, because we're dealing with a pyramid, or not. Equilateral triangle. That's what we're dealing with. So we have to use the area here. So the area is equal to square root of 3 over 4 times s squared. So s, so all these sides are equal. So we can just choose one of them to figure this out. So again, I just lost my spot. Again, we are using equilateral triangle for the area here. 6. Yes, okay. So the base, or s equals 1 minus x over 2 minus negative 1 plus x over 2. And this is just going to equal 2 minus x. So this is how we find the length of the base. After that, we just plug that in for s. So we're going to do area equals square root of 3 over 4 times the base, which is 2 minus x squared. Now for the volume part. So volume equals from A to B, so they intersect at 0 and 2. And it's just going to be A of x, D of x. So this is going to look like from 0 to 2, since it's just a triangle, we are just plugging this in for A of x, so square root 3 over 4. Sorry, we're plugging in this one. 2 minus x squared dx. Pull the square root 3 over 4 out, so we're going from 0 to 2 of, and then we can factor this out. So 4 minus 4x plus x squared dx. I think I did that right. I don't like going backwards like this. 4 negative 2x, yep, negative 4x. Yeah, okay, good. Did it right. So easy integration from here. So we're going to do 4x minus 4x squared divided by 2 plus x cubed divided by 3 plus c from 0 to 2. Simplify this down a little bit. We're going to get square root of 3x. So I'm distributing this to each of these. So the 4's are going to cancel there. Minus square root of 3x squared over 2. Again, the 4's are going to cancel there. Plus square root of 3x cubed over 3 plus c from 0 to 2. So when we distribute the 0 for the x's, it's just going to be 0. So now we just have to compute what it would be for 2. So square root of 3 times 2 minus square root of 3 times 2 squared over 2 plus square root of 3 2 cubed over 3. I'm gonna come up here. I'm actually gonna do this on a calculator. Square root of 3 times 2 minus, this is canceling with one of these, so minus square root of 3 times 2, so that's actually just going to be 0. So we're just left with square root of 3 times 8 over 3 is going to be our answer for that. I apparently did that wrong. Where did I go wrong? So they use substitution instead of whatever I did. It should come out to 2 square root of 3 over 3. Back and check. Cancels. Aha. 4 right there. So this actually is 12. This needs to be a 12, which equals that. So I did it kind of right. Final answer. Okay. So that's how you do that. Let me know if you have any questions about it, and I'll help you out as best as possible.